everybody. In this section, we're going to learn about something called limits. There's a lot going on in this section because limits are foundational to everything else we do in calculus. So please allow yourself some extra time for this section. The idea of a limit is that it's a destination. So let's say I'm driving to Chicago. My destination is Chicago. And let's say Chicago is right here. And let's say this is my road. Let's say that's Interstate 55, which I think goes through Chicago. Okay, so I'm driving along from either direction, who knows. Here's how we can abbreviate this scenario. Instead of saying out in words, I'm driving along I-55 and my destination is Chicago, we could abbreviate that idea of destination. I'm going to call it DEST. And then I'm going to say that I'm on I-55. So my destination along I-55 is Chicago. But there's something else I need to get in here for this to make any sense. Because just because I'm driving along I-55 doesn't mean my destination is Chicago, right? I mean, suppose I was coming along over here, then I'd have a different destination. So I need to say where on I-55 I am to explain why my destination is Chicago. And most highways have mile markers, so let's say Chicago happens to be at mile marker, I'm going to call it mile marker A. For reasons that'll become a little clearer later. So if I wanted to say where I am along I-55, I could say that I'm approaching, and I'm going to say that with a little arrow, I'm approaching mile marker A. So my destination as I drive along I-55, approaching mile marker A, is Chicago. And remember that word is in math always translates to an equal sign. Speaking of math, let's turn this into math. I've got a graph, so I need coordinate axes here. And instead of calling this graph a highway, let's say it's the graph of a function. How about f of x? And mile marker A I'm going to represent by putting an A down on the x-axis, because we always talk about where things are happening on our graph by referring to where on the x-axis you'd have to be to look up and see that thing happening. And then what's the thing that's happening? Let's say the y-coordinate of Chicago is capital L. This lowercase a and uppercase L, those are traditional letters in this context, by the way. Let's now rephrase the whole destination idea in terms of the math we just introduced. And remember, the new name for destination is going to be limit. So I could say something like the limit, remember that just means destination, as I approach x equals a along the graph of, I'll just say f of x, is L. So the destination is the y value. How am I getting there? I'm approaching along f of x towards a, towards x equals a. Let's abbreviate that similar to what I did right there. I'm going to abbreviate limit as LIM. I'm going to say what road I'm on. I'm on the graph of f of x. Then I have to say where on the road I am. So I'm going to say the x's are approaching a. And then my limit is, remember in math that word is becomes an equal sign. And what is the limit? What is the destination? It's L. So where is this happening? It's happening as x approaches a. What is happening? I'm approaching destination L. As you can see, there's two other scenarios that I'm going to have us look at. But before we get to those, let's see an example. Let's find the limit as x approaches 2 of x squared. Here we've put the function formula in for the name of the function. So another way to phrase this would be to say, find the limit as x approaches 2 of f of x for the function f of x equals x squared. But you can see it's shorter to just put the function formula in after the limit notation. Let's label our axes, and let's indicate the scale. So this is 1, 2, 3 on the x-axis, and 1, 2, 3, 4 on the y-axis. It's important to always do that. Let's label our graph. It is the graph of f of x equals x squared. And the x approaching 2 with the little arrow underneath the LIM tells us to think about approaching x value 2, but as we move along the graph. So we're thinking about coming in either this way or this way towards the point where the x coordinate is 2, and we can see that the y value there is 4. So our answer is the limit as x approaches 2 of the x squared function is 4. So as I'm traveling along the f of x equals x squared function, my destination is 4, assuming I'm traveling along it with my x values approaching x equals 2. Notice that in this example, you'd be able to find the destination, in other words, the limit, by just substituting the x value into the function formula. So my function formula is x squared. So if I put in the 2 in there, I get a 4. That's why that point 2, 4 is on the graph, and that's why we're approaching y value 4 as we move along the graph there. Now, much of the time, and what we're going to do, that's all you need to do to determine the limit, is just to put the x coordinate into the function formula. And so that would very naturally lead you to ask, are these two things really the same? But if so, then why are we introducing all this limit stuff when you could just as well say that when x equals 2, y equals 4 on the graph of the function? Well, these are not the same. Even though we get the same numerical answer for both of them in this example, they're still not the same, should I call it thing? How about I call it, I guess, idea. If they were the same thing, we wouldn't be going through all this limit stuff. So, why aren't they the same thing? Let's go back up to our scenarios. And that's what the second two scenarios are to explain. But I think this video has gotten long enough, so let's start here in the next video.